Yeah.
Yo, bro.
Gee, we have a student already.
All right, fair enough.
Let me call you. Let me call you back on your phone.
Yes.
Okay, we promised to wait like for 5 minutes, and the 5 minutes over now, so let's get started. But before we get started, I would like to ask or have some feedback from you guys. Like, how did you experience yesterday's session? And basically, what is your opinion like? Do you think like, okay, it helped you further in understanding the exercises we discussed yesterday? Feel free, you can put it in the chat, or even better, unmute yourself and say something. Okay. Let's see. Okay, thank you for that, guys. I appreciate it. Yes. Thank you, Alexander. Yes, merci. Okay, so with that feedback in mind now, we can also use the same strategy so you understand the exercises we're going to discuss today. As you guys could see yesterday, we went through these exercises. So as if I'm not mistaken, it is Alexandra just mentioned that this first question, we did it like step by step, so you get like the intuition how to solve it, after which we went through this a bit quicker. So after getting the intuition, for you also during the exam, maybe you can even do this one in 5 minutes and then go along with the next one. And oh yeah, I have to record.
This meeting is being recorded.
Thank you, Noor. So we went through. Let's see. So we went through this one a bit quicker because we already had the intuition how to do it, and eventually we came to question 2, which we discussed step by step and even revised it. Some people had some questions. I showed you. I tried to show you guys like in the first section how we could derive the UNV without looking at the UNV that was already given, just by looking at the system of equation that we had in our third row. And you will see that after giving you the intuition of yesterday, that the third question we will be discussing today will be very that intuition will be very useful in that matter, because that is the same thing we have to do to derive to be able to answer that question. So namely this third question of the exam. As I told you guys yesterday, the exam of linear algebra is more or less not big. They won't give you like 8 or maybe 10 questions. If you're lucky, you have even the research exam last year was just 3, consisted of 3 questions, and the actual exam was 4. So if you're lucky, you have 3. If you're not lucky, you have 4. But then they will take it into account that that you might need some more time or not. But let's look at this problem. So the problem says that we have a linear map T from a 3-dimensional X space to 3-dimensional Y space, right? This is defined by Y, and Y and the equation that we have of Y is Tx is Ax. Guys, please keep in mind, like in basic math, if I say this equals to this, that means that they're more or less the same, right? If I say Y equals to 2x, so that means that what comes out of which variable I take of x and multiply it by 2, that is what I have. But if I also say at the same time that is equals the y is equals to 2x is equals to some ax, that means that what comes out, the value of y is the value of a. In this case, if we say y equals to tx is equals to ax, so we say that our matrix ax is equals to what we can possibly have in tx. For now, I don't know what tx is. We will see it in when solving the system of equation, but just to get the intuition what is meant in the problem. So if we look at our system of equation, we have again just looking at the, let me take my mouse. So just looking at the axis. So I'm not taking like the y's into account for now. So I will be like, I will just count 1, 2, 3, 1, 2, 3, 1, 2, 3, and then 1, 2, 3. So I know I have a 3 by 3 matrix, right? Again, I said we can always add the y's to it, which will make it 4 by 3 matrix. So that's like we see, like we discussed yesterday in this case. After we had this system of equation, we add the y's to it to make it a 4 by 3 matrix. So that's, if you look at something like this, try to get the integration and then read the question, what you have to do. So they say use a row reduction for ax is y. And then I will go back to the last, to the previous question. So you see it again. It is not the same. Yesterday we said ax plus x is y, and that x was the identity matrix. In this case, there is no x, so I will not add anything to it, no identity matrix. I will just keep on what I have. So they say ax is y. To show that, RT is equals to column A is given by one linear homogeneous equation for y1, y2, and y3. So that's the intuition that you get. We're talking about homogeneous equation now, so we know that we can add the y's to it to make it 4 by 3 matrix. So now we're gonna do some row reduction to have, and the for this one we have already solved this yesterday. But with this question, we already solved that system of equation, because now what we are going to do, we are going to reduce it in a way until we have on the last row we have 3 zeros, and then we have a system of equation of y, and then we're done. We just write that y1 something y2 something y3 is equal to 0. We're done. That's all we have to do, because they said that we have is given, and so we have to reduce it until we have a homogeneous equation of y1, y2, and y3, and then you can determine which is dependent on which, but that's not important now. The most important thing is that we just make sure that we have on the bottom, in the last row, we have 3 zeros, and we have our system of equation with the 3 y's. I will continue on this Excel page, because the advantage of that is if I send it to you, you can look at it, and then you can go up and down, and then you can look at all the other questions we have discussed so far. I will call this question 4, but please keep in mind here it's written question 3. Don't confuse it, but just look at the order of the exercises we're discussing, so you get it better. So I will call the question 4.1 or I. So basically, what I will do first, I will just give you like the system, the matrix, and in this case, again, I will call it A because it is ax. I will say A equals to, as we used to do. Please keep in mind, I hope again that you take a picture of it, because I won't be repeating that. Let me go. Let me show you again, because you know that this is 1, this is a 5, this is a 4, this is a 2, 6, 2. This is a 3, 7, and this is a 0 because we don't have anything. This is a 1, this is a 0. Keep that in mind. So like you don't get confused when I write out the matrix. So basically saying that if you took picture of the system of equation, you should have this. Then I have 6, and then I have 2, and then I have 3, 7, and 0. So far so good. So basically this is A, but what I can do, and again just for myself, I will remove the A here, I will put it up here, because then it's in the middle. That's something for myself. You can do it the way you want to do it, but for me, when it's in the middle, it's centered, and that makes more sense. So what we can do now, now that we have the matrix, we can reduce it, right? Well, then don't forget to add the y's to it. So in order to reduce this, you really need to add the y's to it, because the question that is asked is to determine what the system of homogeneous equation is, the linear equation, right? So then we need the y1, we need y2, and we need y3, right? So we have to add this to our matrix to be able to do it. So I just wrote what A is, and from here I will start with the row reduction. So be with me. And again, like yesterday, the star is our sign of multiplication. Don't confuse it with any other thing. It's just our sign of multiplication. I'll use the star at the top because like my pivot column has 1. I don't have to change it. I'll just make sure that I get rid of these 2 in the first in my first calculation. Again, I'll just take -2 because in this row I have like the 2 in the first column, and in this row I have 3 in the first column, so I will take -3 just to make it easier for myself. And eventually, as Berend said yesterday, we'll just take our equivalent sign and put it there, just because I want to stay according to what the book said and the way linear algebra is calculated. Okay, now again, as I said yesterday, I can just copy this, and if you are the one doing it on paper, you just write that row, because that's the row I have my multiplication sign, and then I will start. I know that if I multiply 1 by -2, I'll have -2. I add it to 2, I will have 0, right? And that same and here in for 5, if I multiply -2 by 5, I will have -10, and I add it to this, I'll have -4. And ultimately, that same counts for the third column. If I multiply 4 by -2 and I add it -2, I will have -8, and I add it to 2, I will have -6. And then again, you know that we already have y2, but if we multiply y 1 by -2, we'll have -2 y1, and then we can add y2 to that, so we have plus y2. And then finally, we'll go to our last row. We are getting rid of this 3 to make it 0. Okay, so we'll multiply 1 by -3 is -3, and then we add it to that is 0. And then we have -15. -15 plus 7 is -8, and we have -12, and it stays -12. Why? Because we have a 0 there, right? And then again, we will have like a -3 y1. We can add that to y3. So far, so good. I think like this is nothing new, because we did this yesterday to get the intuition how to derive our y and say our w, and say, okay, if our w is our eigenvector, then -1 should be our eigenvalue, right? So by now there's nothing new. So what we can do, and as you guys know already, if I already reduce the first column to zeros, I will make sure that I get rid of the last row. So like the 2 values in the second and the third column, I will make sure that I make them zeros. So at the end of the day, I will have like my linear equation that consists of the y1, y2, and y3. So now what I will do, again, this is just my sign of multiplication, and then I will look, okay, this or this is half of this, or this, or you can say this is the double of this. It doesn't matter. It's just up to you how you want to look at it. Just sometimes just look at your matrix to have the intuition. What kind of matrix do I have, and what kind of numbers do I need to go through it? It's better to take like 2 or 3 minutes to get that, so you do it properly, instead of that. Some people will try this and then try that. Most of the time doesn't work out. So be very intuitive in what you're doing. So I know that this is half of this row, so I will just take -2. Why I'm taking -2 instead of 2? Because this already has a negation. It's not already negative. If I multiply with negative to positive and add it to something that's negative, I will take a better difference. Again, these 2 columns will not change. Let me do it differently, because I don't know if I will take the whole thing from there. If I go there first, let me be consistent, because that's important in linear algebra. You can just, they can just reduce points because you're not being consistent. So again, I know, okay, this is 0. Everything multiplied by 0 added to 0 is 0, so nothing changes. And now the funny thing comes, because after this, we more or less have the answer. This is going very quick, fortunately, because of the intuition of yesterday. So we multiply -4 by -2, we have 8. We add it to -8, we have 0. Then we go to the next column. We multiply -12 by -2 is 12. We add it to -12 is 0. And finally, bear with me, we are here now. We have to multiply this by -2 and then add it to what we have here. Just for the sake of simplicity, I will go down here and do it again, because I can imagine that you have maybe have maybe forgotten that, which is no problem. So let's do it again so you get it. So I will just multiply the -2 by -2 y1 plus y2. So then I will have 4 y1, and then I will have -2 y2. So far so good. And then I know I have to add that. So I have to add that to -3 y1 plus y2. I know I have to add it to it, but if I add the plus and then I have -3, I can just get rid of the plus. I can just say immediately, okay, minus y1 and plus y3, and this gives me the following. What you should look at, the only computation that you have to do is the y1s, get rid of or reduce it to just one single variable of y1. So I know that, okay, if I reduce that, I have 4y1 minus 3y1, I will end up with y1, and the -2 y2 will stay, and then I still have my -3 y3. No -3 y3, but just minus, but just plus y3. Yes, nothing changes there. Yes, this is it. Does this make sense? So far so good, guys? Because like this is the answer of our first question. Let me copy it and stay consistent, paste it here. So we have our matrix. I will just get rid of this. I'll just get rid of this. So this is like we have reduced our matrix until we have our zeros down here, and to stay in the terminology, we have a homogeneous equation for y1, y2, and y3. So that's what we have done. What we have to do now, because like you should be consistent. The final answer is this. You have to equal this to 0. This is your final answer. So keep that in mind. After doing this, don't just say I have this, and please don't forget to mention the theorem. Like the professor said in the lectures, like if you show something, say what which theory you're using or which theorem you're using, and then try to explain it. So for that, go through it so you get more intuition about this theorem. And that's. I saw that my internet, I just saw that my internet was unstable. I will just repeat it. I said that this is the final answer. And what you should also keep in mind, as Eric said during the lectures, that you should make sure that you use theory from the book and theorems from the book, because like if you give a calculation, make sure you link it to a theory or theorem and explain why that holds. So keep that also in mind, so they do not deduct points from your final answer. So basically, we have solved
but you also cut out. I think you were about to tell us what theorem, or just remind us what it was, because I don't know.
No, I was just going to remind you guys that. Okay, let me see why my internet is being stable. Okay, that's crazy because it doesn't look. It's full. Well, what I was saying is that you should keep in mind that if you compute something or you solve an equation, that you say, okay, what kind of theorems you're using and why you're using it. because the professor put some emphasis on that during the lectures. But for the theories, please go through the summaries I sent you so you get more intuition about that. My goal is now to get you to the exam, so how you can solve it. And for the theory, please go back to the book or to the summary I sent you. So we have solved the first one. This is the final answer you should write down. Okay. So after doing that, let's go to the second question. But what is, if you look at the second question properly, says find all factors which are perpendicular or orthogonal to RT, right? Because if you read the first question, it says use row reduction for X is Y to show that RT is column of column space A. So we have that just solved what RT is. Now we're going to find all the factors that are perpendicular to that RT, right? So more or less, what you should look at, like sometimes it is enough to say, okay, what are my pivot columns? I can take that. You can take your pivot columns. I will do two things. I will show you the hard way, and I will show you the easy way. Then it's up to you to choose which of the two you will use. But so, and that all depends on the amount of time you have during the exam. So be very efficient with your time. As I told you guys yesterday, I will go back to that exercise where I said, okay, I stopped here and I said, okay, I have this system of equation already. I can set that to 0 and I can determine what my U and V are, right? But after which I went down here, I further row reduced it, and I saw that these are my pivot columns. The fact that these are my pivot columns, and I told you guys already, if that is my pivot column, I can go back to the to the original. Let me see. I can go back to this matrix and say, oh, in that case, I know that because of my pivot columns, that these two can be held as like I can call that these are perpendicular. I can say that these are perpendicular to something that I have. So in this case, I would say RT or something. But these are perpendicular because those are my pivot columns, and that's all because of these after row reduction. So if you have that intuition now from yesterday, we can row reduce this further, but I know for sure that I will end up with these as my pivot columns. So I can just go back to this system of equation and just copy these two, because I know for sure that these will be my pivot column, and then I will show you first of all the hard way how to row reduce, how to go along with this, and after which I will show you the easy way how to do it again. Right? I solved myself. So if I have this system, which I should, I mean, if I have, by the way, these are two factors, and I have to rewrite this to make it a matrix, okay? And don't take them like this, because we're taking something that should be perpendicular, so we are going to take it 1, 2, and 3. And then this will be 5, 6, and 7. So far, so we have a 3 by 2 matrix. I will show you the hard way. We will reduce it. I will show you the answer, and then I will tell you we could have done it like in 2 minutes. But let me show you the hard way. So again, I will reduce it, because as you can see, they said like we have to find all the factors that are perpendicular to the orthogonal RT. So let me reduce it. I know this is a 1. I will take -5 here. So if I take -5, this will ultimately give me
Hey, Maliki, there's a question about from Max about why we do this.
why we
talking about
why do we flip it sideways?
or you mean why we flip it the sideways? Because we are looking at things that are perpendicular to it, like the factor goes from 1 to down, and if we flip it, I don't know how to call it, like again, like it's not a dot product. Like I'm looking for the proper word from the book.
Transpose.
Transpose. So we have to transpose it to go through it. Yes, it's transpose, spot on. So we have to take the transpose to go through it. Yeah, so I have 3, there, that stays the same because my sign of multiplication is there, and this will be 0, and this will be -4. I hope you see it. And the next one will be -8. So far, so good. And what I can do now, I can just say, oh, in that case, I can make sure that this becomes 1, because then it will be my pivot column itself by -1 divided by. Sorry guys, I think there's something wrong with my internet today. Yeah, let me put my Wi-Fi off on my own phone. I hope that will help. Yeah, if I get like an insight that my internet is not working, I will repeat what I said. Sorry for that, guys. So I would I was saying that I will multiply this row by -1/4, right? So by doing that, I know that this stays the same. So I still have 1, 2, and 3, and then this stays 0. And if I multiply -4 by -1/4, I will have 1, and here I will have 2. Ultimately, what I can do now, as Max already said yesterday, that here we could also have already multiplied this by 2/9 to have this as 1 for the sake of simplicity. That's what I've done here now, so you can see it. And now what I can do, I can use that row to get rid of the 2. If I get rid of the 2, then you will see it, and then you'll be like, oh. Now, system of equation that I will create is as follows. So I know that the 0, 1, and 2 will stay. So I can just rewrite that and then forget it. And then I will start my multiplication. This will stay 1. And then I know that I'm getting rid of the 2. So -2 times 1 plus 2 is 0. And then I know that this times -2 times 2 is -4 plus 3 is -1. And then now the funny thing with this system of equation is that we know if this is x1, we can say, oh, in that case, I mean, or if this is y, if this is y1 and this is y3, we can say y1 minus y3 is 0, and y2 plus 2y3 is 0. So we know that y3 is the free variable, which can help us to determine the w, right? So in that case, I can go down here. I'm just taking this over, but then in terms of y1 minus y3 is equals to 0. And then I can say y2 plus 2y3 is equals to 0. And then I will say, okay, in that case, I know that my y3 is the free variable, right? So far, so good. So if we already have that, what we know that we can we know that we can state the following. We can derive from this. I'll just go here. We can say, oh, in that case, I know that y1 equals to y3, y2 equals to minus 2y3, and y3 stays still the variable. I would just say 3. And don't confuse this, it's just is sign because it's math. Well, let me just say it's 3. Okay, so then my w in this case will be, can someone say it looking at this? What is the w then? W will be
1 minus 2, 1.
Yes, sir. Thank you. This is my W. So now I know that I have these columns, right? And I have these columns, so I have all the columns that are perpendicular to the orthogonal RT. This was the hard way. Now I will tell you the easy way. Let me write it down here. Easy way. Oh, yeah, easy way. The easy way told us, like the intuition we should get, we should know that even if it says the second problem of 4, we know we can still build up on the system of equation we already had, right? The system of equation that we already had there told us that, okay, what will happen if we want to determine, because this is the y3 is dependent on y1 and y2, so from which we can determine what our u and v are, right? And I told you guys yesterday already, if we determine the u and v, please keep it simple. First take 1 and 0, and then take 0 and 1. Don't make it difficult to yourself. And if you go back to yesterday's, it's more or less the same. So the u and v will also stay the same. Nothing will change. So the u and v will still be, if we just took the u and v, and the easy way, just think, okay, what is my u? I would tell you then, okay, in this case, the u is 1, 0, minus 1. And then the v will be 0, 1, and 2. If this was the case, and I take the transpose of u and v, now you will see the trick. You will like, Maliki, why didn't you do this in the first place? I will end up with this. I'll end up with 0, 1, 2, right? Which is the same as this. That's the easy way. And then you can use this same system of equation to solve it. So if you had reduced it until here, and then ask you the second thing, you could just retake this and then calculate your u and v, take the transpose of that, and then you don't have to go through this whole row reduction. But it's all up to you. If you want more insight, you can do that first one. Or if you like, okay, I have some time shortage, just take the u and v. It will really help you. Any question about this?
I said it in the chat, but so this way you can say that the u and v are equivalent to the row reduction of the pivot columns of A.
Yes, sir. Yes, sir. Yeah. Yes. If there are no questions, I hope you see it like we did the hard way and the easy way, and the easy way is like in 2 minutes. You can go to the next question, or the hard way, if you want to be certain of what you're doing, just do it the hard way, please. Yes? Okay, in that case, I'll go to the third problem. So the third problem says, by the way, the third problem is more or less like a theory question. It's not like they said determine the, and for this you really need the theorem, right? They said determine the null space of the transpose of A. And for this, like because there are certain theorem, I will just write it down a bit in the Excel sheet so you get it. So they say if we are going to determine the null space of or the null space of a transpose of A, you have to come up with the following reasoning. So just in case that what you have to do, you have to observe what we have solved first of all, and then you will say, okay, what now if I have my B? Because at the end of question 2, we calculated our B, right? We said what our B was. So if we say our by is equals to 0, in which B is the transpose of A, all solutions in that will be multiples of what? Of our W. They will all be multiples of our W. So if those are multiples of our W, this will form the basis you can take and set all the factors consistent of W only. So then you're done. So that's the intuition you should get. So when something like this is asked, so you just have to observe that we just solved by, which was equals to 0, right? And again, Let me go up and show you. Like B, we said B. This was our B yesterday. If you remember it, right? So if we saw by which was equals to 0, what we can do. So in which B was equals to A to the power of T, to say that it is the transpose, right? So all solutions were multiples of W, and the W I also showed you, yeah, of this W, right? So what we can say, so this is the conclusion we will take, as a basis, we can take this set of vectors consisting of W only. Does this correspond to like the question? Do you guys get it? Why? Well, when we determine like the null space, so like you should really go through the theorem, what the theorem says, and know what how you can say, okay, now I have my by is equals to 0, in which I can say, okay, my b is in this case the transpose of T. So you have to work out the theorem. So what just the theorem say, make sure you can reproduce that, so you can put that on paper. So and then you can say, okay, in that case, all my solutions were multiples of. I see I have 2 times off. Well, multiples of W. So as a basis, we can take the set of vectors consisting of W only. And I said W only so we can forget the U and V. So far, so good?
I can ask one thing quick. Sorry.
Yes, go ahead.
How did we solve by is equal to 0 and not y is equal to 0?
Yes, that's because of the question. We're taking like they said determine the null space of this transpose of A, right? And then by taking AY equals to 0, in which B is equals to the transpose of A. So the goal is to calculate the transpose of A. So that's why we're taking BY equals to 0.
Like that. Okay, yeah. Okay.
Yes?
Yes.
Any other questions, guys? I know like something like this, it may, especially if you have not gone through the theorems yet, it will sound like abracadabra. Well, if you go through the theorem and see it, you'll be like, oh yeah, it speaks for itself. But if yes,
I have a question. Why is that by equals to 0 and not bx?
Not bx, because if you look at the starting of the equation, it says that we're working with a homogeneous equation for y1, y2, and y3. So as you have seen, like the whole focus this time has just be on the y's, right? Because we have added the y to it. Like in case, like in the first question yesterday, we didn't have any y's. We had 0, 0. All of our focus was on the x's. That's why you could also see the differences in answers. Like if you look at the differences in answer of the first one, we didn't have anything that has to do with y's. Right, we just focus on what A can possibly be, and these are the x's. I mean, I could just say, okay, x I could put x1 here minus 4x2, and this is x3. These are the x's. But here we're looking at a homogeneous equation. Homogeneous equation for y1, y2, y3. Please keep in mind that this whole question is built up, and in the beginning also they say, okay, the linear map T from a 3-dimensional x space to 3-dimensional y space is defined by y is. So we really want to know what the y's are. Yes?
Okay, thanks. I think it's clear now.
Yes, you're welcome. If there are no further questions, I'll go to the fourth question.
You don't actually have to determine it.
What?
You don't actually have to do the calculations for this?
No, if you don't have to determine, I mean, by determining it, you have to apply the theorem. You have to explain like what the theorem said. And if you, by the theorem says this, I keep it short because like the intuition that you get, you should observe this. And the theorem said y, by should be equals to 0, in which b is equals to the transpose of a. And then from which you should take all these multiples of w and forget this. So this is like, in short, what the theorem said. The theorem is a bit longer, but this is in short what the theorem says. So this is the determination.
Okay, so you don't actually have to compute.
No. Yes, even if after this I was, as you guys saw it in your mail yesterday, I sent you like the actual answer sheet from the exam itself. It will be the same. I'm not doing anything new like to mislead you guys. Yes. So if we go to the fourth part of the problem that says like we have to find now an orthogonal basis for RT, right? So you guys know that from the book we had like an equation for this, which holds that C equals to minus U times V divided by U times U equals to minus 1. Right, I will advise you guys, please, the chapter that goes about orthogonals, go through it as much as you can and make sure that you know the equation very good, because as far as I know, like every exam I have made so far, they were there. Please make sure you go through them, because I really want you guys to pass this exam. Yeah. But again, I will start with basic intuitions, like. And I said like all the problems, like I mean the first one, second one, third, and even the fourth one are building elaborations of the whole problem itself. So it's still the same problem. So I will take my pivot columns again, that from which I took the transpose to be able to calculate what the other things are. So in this case, I know that I have 1, 2, 3, and I have 5, 6, and 7. I'm not doing anything new because it is the same thing I had here in the second part. Nothing new. I'm just retaking it. So if I know that my pivot column factors were that, and even nicer, what I can do, because I told you guys, if I take that, I will have to do more computation than necessary. Well, I could also just take the. I could just also take the U and V. I will put all here. That's all up to you guys. Like I will show you both ways, and then it's up to you to decide what works for you. Because as I said, math, everyone knows, everyone wants to do it on their own. Do it and you'll make sure you have the same answer as other people. So what we should do now, I told you like the equation is already C is minus U times V divided by U times U. So we should think about an equation that says, and this is also exactly from the book, that says we should choose C such that U minus C, I mean, sorry, it's not U, but V minus CU has like the inner product, right? The inner product, which is 0 with U. And this will give us then eventually our calculation. So what I was saying, that if we have U minus CU, so by choosing C, we should make sure that we choose C in a way that that it has like an inner product 0 with U. So that's just an intuition you should get. So after this, you should know that, okay, the equation for the orthogonal states as follows. It says that, okay, we have minus U, which will multiply, again, this is my sign of multiplication, which will multiply by V, and then we divide it by U times U. And then we say in that case it equals to, let me put it here, it equals to minus 1. Wait, I know how to do that. Equals to minus 1. Does this make sense? So this is exactly from the book, like nothing new. Like if you want to get more insight in this, please make sure you go through the book. So what we can do, we can take the U and V. So we can take U and say, okay, if we have v minus a cu, which I have here, is equals to v plus u. Like I would just like if you see the answer like with just the u and v, you'll be like, okay, that it went very fast. Why? Because I'm just using the v and the u again. So from this, I can derive. I can say, okay, in that case, what starting from what I did here in the beginning, I would say, okay, now I can say my u minus my v minus cu can be equals to v plus u. And I know that this is my u and this is my v. And even without calculating it, if I look at just the rows, I can know if I add up this, what will happen if I add this to this and add this to this. So intuitively speaking, I know that I will have.
Sorry to interrupt you, Maliki, but there is a question about minus u and why it's minus u.
Oh.
Why is it negative yet?
Like, it is not just the u that is negative. It's like it's just because of the system I'm using. Like, intuitively speaking, this u would be before the whole. It is u times v divided by u times u, and but a minus before that. So it is minus, then you have u times v, and then v times v. So it's wait. Let me try to show you guys from different perspective. But then let me go here and let me show you guys with proper, because I think from here I think even that's possible in Excel, right? That I can functies. Never mind. Let me see. Like, yes. So what I was actually saying is, I say, okay, C equals to this, and then I have minus. So it is this u times v, and that divided by u times u. So it is this. It's not that I'm negating the u. Can everyone see this? Oh. This is what I meant. This is from the book. Okay, so this is what I was trying to replicate here. So keep that in mind. It's not that I'm negating this section, but it is like this, and that's from the book. Please keep that in mind. Okay. So from which we can say, okay, then we have the following. If we combine this this equation, what we can do, we can add these two together, because I said we have this inner product of being 0. So if u is with u 0, if u is 0, then we have just v minus c, right? And then we can, if we add these two together, so saying that we have v plus u, that will give us the following equation. I will just write it step by step so you see it. I will have 1, 0. I have 0, and then I have minus 1, and then I will just put the plus sign here so you see it. So plus the other thing, which is and 2, right? And then this should equal 1, 1, and 1. So this is like the easy way of doing the fourth question. If you guys want, I can also show you the hard way with the pivot column. Shall I do that too? Because then
yeah, I think it's nice.
Okay, thank you. I mean, I wanted some other people to say something, but no one is responding. Well, no problem. So, so if we take the pivot columns and then which is more or less like less convenient, but let's take the U and V. So and then we call it now in this case the U and V's because they're the pivot columns. So this will be U, and then I'll just say, okay, this is the V. So this is my U and this is my V. Okay. So still, I still know that and by the way, if I use this, I will end up with some fractions. I still know that I still have to apply this by making U 0. So or taking like the inner product of with U 0, right? So if I say that, I will let's see. Put a scale that I will have. So if I apply so if I apply this same thing, I will end up with the V by saying, okay, I have my say, okay, then I have my 1, 3, all right, and then I say, okay, I will add them together, and then I have my 5, 6, and 7, right, which should equal so I'm just going to write it out first, and so you get the intuition, and if we add them together, we have 6, we have 7, and we have 10. So far, so good. But then we still need our C. What is our C? To calculate our C, that's why I said this is the hard way to calculate our C. I mean, with the U and V, we just have like 1 minus 1, so the 0 doesn't have much value, and we have 0 here and we have 1 and 2. So to compute the C here is very is easy. So that wouldn't be a problem. So in case we have to.
Is it 6, 8, 10, or did I misunderstand what we're doing?
It's 8. Yes, my bad. Yes, it's 8. So like now, first of all, I have to compute my C to know what my C is, because if I have my C, I can then scale my equation with the following formula. Let me take saying that, okay, then I have my V minus CU, right? To scale this, I will calculate my C. So my C will, what my C will give me by applying, please, to calculate your C, you should apply this equation here, which is this. And the U is not negated. It is that the negation sign comes in front of it, right? So if I go back, I will say that my C should give me 19/7 if I compute it. Does this make sense? After computing it here, we will end up with this, because I know this is my U and this is my V. I can compute them here to get the my C as answer. So, and if I have my C as answer, what I then can do, I can scale this factor to have a proper factor by saying that, okay, in that case, I can follow on with saying that, okay, what my V can possibly be. Then I will say my V can, my V minus CU can be this, can be the following. Then as I told you, it's the hard way. Now we have a lot of fractions in it. We'll have this. So keep because I'm computing what V minus C, you taking into account that this is my C. Okay. So I have 4 divided by 7, and at the end of it, I have minus 8 divided by 7. I'm not done yet, because I will scale this down to give you more insight that about the answer. So after having this, I will scale it down. The way to scale it down is to make sure that you know that this is 7. That you should make a system to which you can divide 7 to. And after this value, we'll go for a break. And after scaling it down, let me scale it down here. Scale down to the following. So I will get the following factor. And the factor that I will end up with will be 4, will be 1, and will be -2. And ultimately speaking, we can say, okay, this is perpendicular to what? To this, to the u. Because please keep in mind that this is my v. That I can say I can move the cu to the right hand side of the s sign, and then I have v is cu. So then I have calculated what my v is, and then I should make sure that I say this what I've got here after scaling it down is perpendicular to what my original u was, and that should be 1, 2, and 3. Then I've solved it. So this is the hard way, as you can see, like the difference from what we did here and what we have done at the end of the day. Yeah. Any questions so far? I know like this, like I mean, the beginning of the exam is always easy, and then the third and the fourth question is doable, but like the third question will be the hardest all the time. And for the reset, I think it was the second question that was the hardest, because it just consisted of 3 questions. But for now, I will give you guys like a 15 minutes break, and I will zoom it out like yesterday again. Today I don't have to eat or anything, so we will be back exactly in 15 minutes. You take your time and go through what we have done so far, especially like I think the third and the fourth questions, where I showed you guys both ways of the second and the third and the fourth question, where I showed you guys both ways of doing it. Please go through that so you get more intuition.
And can I ask you something before you leave?
Yes.
So we had to determine an orthogonal set, right?
Yeah.
So
wait, let me go back to the questions. So we look at it. We have to find the orthogonal basis.
Basis, I mean.
Yeah,
a
for
basis.
our
And the
system,
basis is
yeah.
a set.
No, not exactly. I mean, like a basis of orthogonal is not like the same as the set of it. As you can see here, like I said that if we take all multiples of a w, so as a basis, we can take the set of vectors. We can take the set of vectors. It's not necessarily like the basis is the set of vectors, but we can take the basis as a set. So make sure you don't interchange those way of thinking about it. You take something as a set of something, but it doesn't mean that the basis is the set.
Yeah, but the basis of a set spans the vectors, right? The space, right?
Yeah, it maps to the space.
Yes, so it spans it. But how can one vector span a space?
How do you mean?
So we have this scaled down vector, right?
Let me zoom it in again. So we have the scaled down vector, which is this.
Yeah, and the question says find an orthogonal basis for RT. And
So
a basis,
a
a basis is it's how can something be orthogonal if it's just one vector?
How can it be orthogonal if it's just
you need two to be orthogonal, right? Otherwise you don't have an angle between. So
because like here we started with the u and v, right? And then we find this, and I said this is perpendicular to this, so we know that we.
Oh, these two are orthogonal, and
yes.
these two vectors form the basis for RT.
Yes, sir. Because this is perpendicular. That's why I also wrote this one down.
So, like as final answer, shouldn't you say that the basis for RT is this set of vectors?
Yes. Yes.
Okay.
Yes. Okay. After that being said, let's go for like we'll start like at 16:20.
Just before you go, there's one last question in the chat. It's about C, and that's
C.
Yeah, and basically Sasha is asking if
It's not
it's supposed to be negative. Yeah.
negative. No, it should be positive. And I gave the intuition by saying that if you look at this and say, okay, what can my v possibly be? I can say, okay, v equals to c u, and then I can also move the u to the other side and still have c. So like it depends. And then if you compute it shouldn't be negative. It should be positive. And I said this equals to -1. But what I also just, let me go back to the, but I showed you. Maybe I didn't write that. This equals to -1. So if you applied -1 to it, it was still positive. I think at the beginning, because I didn't show that that was there. And this formula is in the book.
Okay.
Yes, Shasha?
I'll take a look at it because I got a
Yeah.
little confused because when I multiplied it out, it was positive. But
Yeah.
maybe I just did it wrong.
I see the confusion. I think because I will just put the minus and I didn't show the -1. So that might be the confusion. Then it should have been negative, or please keep in mind that there's a -1 here.
Okay, thank you.
Yes, you're welcome. So see you guys in a bit.
The recording has stopped.
So we back again for the last bit of the exam training. We will discuss like the fourth question from last year's exams, the final exam. As I told you guys already, the exam consisted of 4 problems, right? And the reset exam consisted of 3 problems. So what we have done, so like me, Ramsey, and Amalia, while we were designing the discourse, we decided to, as you could see, most of the time, if I did like problem 1 here, I also took problem 1 from the reset exam, and but this problem 3 here, I put other problem 3. And the purpose of that is this is a bonus question you guys can use and go through. And if you have any other question, you can just email us or text us so we can help you further. This is something, it looks more or less like the third as the third exercise from the final, but it's not exactly the same. There are some insight because we determined the null space. We have already done it. We give the equation of RT space in Y space. So we say, okay, this is our Y and this is what it can be, and we can find all the orthogonal bases. And that's also what we have been doing here. By here we found the orthogonal base, and okay, the transpose we didn't do that, but we found all the factors that was perpendicular, and also from here we found the homogeneous equation in Y1, 2, and 3. Please don't get confused when they say, okay, give an equation of RT in Y space. It's the same. Don't make yourself be confused. And of course, I will send you all the answers, because I realized after mailing you guys yesterday that I didn't send you the answer sheet of this. I will make that good today. I will make sure I send you all the answer sheet. So no one said it, but
This meeting is being recorded.
good. So like I didn't send the answer sheet of the resit exam, and maybe no one has gone through it yet. But for now, we will work on this, and then we'll stay here on the and try to answer some questions about the previous exercises we've done. And please try this at home. And I will send you the answer sheet. Don't look at the answer sheet until you finish it. So after this training, I will send you the whole exam of last year and the resit exam of last year and their solutions. Okay. So for the fourth problem last year, they said, okay, let the matrix with entries. So we have, as you can see, as you can look at the entry with these entries, I would say. And then the question was, we should compute the eigenvalues of A. I mean, if you guys remember it yesterday, when Berend asked me, it was with not this problem, it was with the second problem, where we already knew what the eigenvalue was -1, and but the trick was, they said, okay, this is the eigenvalue, you get it, it's for free, but now more or less compute the corresponding eigenvectors. But in the fourth problem, they didn't give us any intuition what it could possibly be, and again, they didn't give us any eigenvector. They gave us a matrix with some entries, and then from which we should be able to compute our eigenvalues, because you see that it has multiple eigenvalues. Okay, I'll continue on this sheet because that will help you in the future when I execute it as a PDF. You have everything in one PDF. So again, here I'll continue with question 5. Then I will take the I. So what I will just do now, I'll just rewrite what the entry is. Again, as you have seen, like throughout the whole exam training, all our matrices has been called A. Again, nothing new. I will just call this A. So in this case, my A is quite simple, because I have in my entry 1, 1, and 1, and I have 1, 1, and 1, and here I have -1, I have -1, and I have -2. I have not done anything yet. I've just copied this. But as we know from the book, there is a rule that holds if we are trying to find, so by the way, I will leave this for what it is now, and then continue here to give you first the insight, and then calculate it with you. If we are going to calculate our eigen values, what we should know, we know what our A is already, right? But we should subtract the identity matrix multiplied by lambda. That's capital I. It looks like L. Maybe I can copy lambda from somewhere. Then I don't have to write lambda the whole time. Okay, guys, give me a second. Let me go here.
I think you can insert it in Excel.
Yeah.
Yeah, pretty sure.
Yeah. Then I have to do this invoegen. Lambda.
Insert and then symbols. If it's there somewhere.
Insert. Then symbols. I don't have symbols.
Nee, ik zie dat niet.
Nee. Gewoon functies. I know how to do it. I can just copy it from here.
Ja,
Yeah. Nieuwe vergelijking. En lambda. And copy it. Yeah, that works too. So I would just go down here, and it is it's multiplied by our.
Maybe you could just write down L like they do in Automata for us. Like a
Yeah,
big L.
yeah. If you guys are okay with that, I will just, for the sake of simplicity, I will just write a big L. But please
I mean,
keep
it's
in
not
mind.
Python, unfortunately. So
Yeah, but please keep in mind that it is lambda. So what I'm doing here, I'm saying, okay, I have my matrix A.
you can do, sorry, you can do backslash lambda. That should work.
Backslash.
Yeah, backslash and then lambda, just type it. I think that works, and if it doesn't, then you can just use it. Oh.
Let's leave it like this, because I think it will. Thank you, Max. I really appreciate it. Thanks. But now we have like our A minus the identity matrix multiplied by lambda. So I will first, as I said, I will give you the intuition first how to do it, and as you guys already know, our identity matrix goes as follows. This should have been 0. This should have been 0. This is 0, 0. This is 1, 0, because our diagonals are the most important things, right? And if I multiply everything by lambda, so also my identity matrix, I know this will be lambda, right? So I can change this to lambda. And the zeros, I mean, the zero stays the way they are. I can also change this to lambda. I can change this to lambda. So far, so good. And then if I take the difference between my A and what I have just written down, so I'm doing like the I'm doing the hard work before I solve my own exercise. So because I know this is what the book says, I apply it to my identity measure. So I'm doing the right hand side of my equation. I'm just doing this, and then I will do the whole equation. So I have one set. So now I'll just copy this. I'll go through it like slowly, so you get it. And then what I have to do, I have to take the difference, right? Let me see if okay, I have to take just say minus, easier so you can read it better. I'll just take the difference of that. If I take the difference of that, and I will say this will equal to the following. This will equal. I'll go with the zeros. You can look at them, but they do not really count. What counts is this one, and this -2, because those will be affected by lambda, right? So if that equals to that, I know that my 1 minus lambda will be 1 minus minus lambda. And then I go to my next column. Will stay 1 and will stay minus 1. And then I have 1 here because I'm taking 0 minus 1 is 1, and then lambda minus 1 is 1 minus lambda. By the way, people that are doing intelligent systems track, next year you have a course called automata. They will do the same thing. They can say either you write L or you write lambda, like in word LAMBDA. So that like it's kind of more or less the same. So again, and then I have my 1 here, I have my 1, and then I have my minus 2 minus lambda. Minus 2 minus lambda. Yes, so this is the system of this is the matrix I end up with, and with which I should compute. I will put it down here. So this was our phase of intuition of what to do, and then we apply the intuition, and then we end up with this. And now the real calculation will start. If you remember from the book and maybe also from the lectures, they said that if we are going to calculate what our eigenvalues are, we can either go it horizontally or vertically. It's up to you. But what you should know that if you start with the first column, that means the horizontal column and the vertical column will not be added, but they can be multiplied to this, right? And what you should know now is, I'm saying, I'll just put it in bracket, saying that, okay, if I have my 1 minus lambda and I take that, what is the next thing I should take? I know that in the system of matrix, I should take this row, this column, and this column. So this 2 by 2 matrix, because these will be excluded. Please keep that in mind, because this exercise, you can easily make errors here, this exercise, because if you forget that you should exclude these and just take it 2 by 2, you will make error. So as I said, I'm going it through step by step. It could be faster, but I'm not going to do it faster. That's up to you during the exam if you want to do it faster or not. So I will write it down like this again. I will do minus 1, and here I will do minus 2 minus lambda. And the totals I can during the exam during the course, that if I take this in the beginning, if I take this as being positive, this will be negative and this will be positive. Right? That's the rule of matrices. That you should know. Like, it is important to know that, especially when you calculate in this. So I know this was positive. So the next thing I will do, I will take minus 1. I will take minus 1 here. So by taking minus 1, I know that the next matrix I will have is, so I'm taking this one. I could also have taken this one, it doesn't matter. But I'm taking this one. I'm going through it vertically. So if I take this 1, it will be minus 1 because it's the next it's the next row in my column. All right. So if I take this 1, that means this row will not be included, and ultimately this column will not be included. So I know I need the 1 minus 1 and 1 2 minus 2 minus lambda. So I'll put this also in parentheses, by the way, to make it easier. So this is, as I said, I'm going through it step by step. That's why I'm doing it like this, like, you know, taking the baby steps so we get it better. And here I will take 1, and then here I will say, okay, minus 2 minus L. So far, so good. As I said, this should be then plus, and then I will take 1 again. The reason I'm putting into parentheses, as you guys know, everything multiplied by 1 is itself, right? So I will keep it like that. So I know in my head this is plus.
You should write this down like that they are determinants, right? The determinant of that matrix.
Yes. So the determinant. I know I will write it like in an equation form with brackets in a bit. But I'm showing like the real intuition, what is meant, what is meant, and how you should do it. So also here, I know this row will not be included. I'm taking the 2 by 2 matrix that is determined by this 1. So 1 minus 1, 1 minus lambda and minus 1. Again, I'm taking 1, and I said 1. So 1 minus lambda, and then minus 1, then minus 1. So far, so good. So after having this, now I will set up the proper equation, how to do the equation. I will use a lot of brackets, but don't get confused. I'm using a lot of brackets so you don't make mistakes, because you know what is between what bracket will be solved first before you add other brackets to it. That's the only reason that I'm using a lot of brackets, just not to confuse you guys. So in the beginning, I will use I will just write this down. I will say, okay, here I will have my 1 minus my lambda, right? And ultimately, what I know too is that I can, that what the rule says, that if this is A, A, B, C, and D, I should multiply A times D minus B times C. Do you guys remember that rule? But because that's what I'm going to apply now. It's just the rule from the book. So what I'm going to do, I'm going to say, oh, in that case, I would take 1 minus lambda multiplied by minus 2 minus lambda, right? And then again, as I said, this times this, and then take the difference of the multiplication of this. So if this is A, B, C, D, it is A times D minus B times C. Keep that in mind. And I know if I multiply minus by 1, it is minus 1. And I take that difference, it will be plus 1, right? Because then it will be plus 1, and I will close this bracket. That means that I have already solved this first part. Is in terms of being consistent, let me remove this one here and put it here. So because all these, when we are on the top, I will also put this on the top, just in terms of being consistent, so you don't get confused. Okay, so after that, what I know is the following. So as you can see, now I will close this bracket. So if you carefully count the bracket, this is in its own bracket. And I open this bracket here and I put this in that same bracket too, right? And then I end up with this, and I close this bracket to close this bracket here, this one. I close it with this, and then the other bracket is closed with this. Keep that in mind. On paper, it's way easier, but on computers, you can see it can be quite complicated. And now this minus comes in handy. If it was the case that this figure was not a minus 1, it was minus 2 for instance, you have to write down the minus 2. But because I know the multiplier, having 1 as a multiplier, it can multiply with everything, and then that figure stays the same, so I can forget 1. I can just put down minus here and then open my bracket again. If I open my bracket, I'm just going through it again by 2 by 2 matrix and saying, okay, this multiplied by this minus this multiplied by this. So for that, I know that 1 multiplied by minus 2 minus lambda, I will still have minus 2 minus lambda. All right. So for that, I will say, okay, then I have my minus 2 minus lambda. And again, I'm not done yet, because I know I have to take the difference of minus 1 minus 2, minus 1 minus 1 and 1. Right? If I multiply those. So if I multiply minus 1 by 1, I know it's minus 1. And by taking the difference, so minus 1 is plus 1. Again, I will write down plus 1, and I will close that bracket. As you can see, I'm being consistent of the brackets. Right? I'm doing that so you guys don't make mistakes. And again, this plus 1 is the multiplier. I can multiply everything by 1, and 1 can vanish. I will just write down the plus. And I will open my brackets again. And in this case, like this multiplied by this, and then taking the difference from this, I will say minus 1 times 1 is minus 1. I'm being 100% consistent. I'm not going to switch it, because I know it would be easier if I would have done this first, because I can have my brackets and then I just have the minus 1 at the end. No, I'm not doing that. This time, this is -1. I write down the -1. And I know I should take the difference and I say minus, and I will open my bracket because I know this multiplied by this, I will have -1 plus lambda, right? So what if I say, okay, that multiplied is -1, and then I will have plus lambda. I will close that bracket and I'll close the last bracket. I should see they are not in the system of a big bracket, but the fact that we have a minus and a plus in between them, we can still join them together, right? Because at the end of the day, using brackets, the only difficulties that you can have if you have to factorize them, or if you have to factorize them, you have like the multiplication sign, because in between here, even though I don't put the multiplication sign, you know from a high school that it is multiple. You can multiply them because you can go from 1 times -2, 1 times lambda, minus lambda times -2, and minus lambda times minus lambda. That you know that from high school already, right? So I will go down here. The first thing I will do, because as I said already, I know this here my multiplier is here and here too, but because this is a system of bracket that is enclosed, I will try to get rid of the brackets here first. So what I will do, I will just copy this and then paste it down here so you see it better. But I know that, okay, doing so, by the way, let me remove it there because I see that the letter type was a bit different. Doing so, I'll just write it down. I will say, okay, now I have my 1 still, and I have my minus lambda, and I will close that bracket. And again, I will open one bracket. Now I'm opening one bracket because I know 1 times -2 will give me -2. So what I'm doing, this 1 multiplied by -2 is -2, and then this 1 multiplied by minus lambda will give me minus lambda. And this system should stay in one bracket because I'm opening the 2 brackets into one bracket. Then my next stop is my minus lambda. My minus lambda multiplied by my -2 is plus 2 lambda, right? So I have plus 2 lambda. And then if I multiply my minus lambda by my minus lambda, I will have my plus lambda to the power of 2, right? And then now I can close this bracket and then close this bracket too, because by closing this bracket, I'm closing the ultimate bracket here. And then in my next,
shouldn't we also take into account the plus
the
1?
yeah, the plus 1, yes. So the plus 1, I will put it here again. I will keep that the plus 1 here. As I said, I'm going through it easily, so I'm not. I know I could already add the plus 1 or open the bracket, but I will leave that for now until I finish with this bracket, making them one bracket, and I can add one to it to make it easier. So now what I can do, because here, like, there's not much to do. I will just take the minus again, and then I'll say, okay, I'll open this bracket, but now I'll break the inner bracket here. If I open break the inner bracket, the only computation that I should do is saying, okay, -2 plus 1 is -1. Right, and the minus lambda stays because there's no term that can be added or subtracted from lambda. So I have my minus lambda, right? And this is this plus. So let me see, nothing wrong there. That's good. Okay, so now we go here again. The first thing I will try to do is open break it. By open breaking it, you know, I have a minus here, right? And if I multiply this minus by this, so minus on itself can always be -1. Just intuitively speaking, even not written down, I can say, okay, multiply by this will be +1, and this multiplied by this will be minus lambda, right? So by doing so, I will say, okay, then I have my -1 plus 1 minus lambda. As you can see, I can get rid of this, but I'm not doing that yet. I'm just going through it really step by step, so we don't mix things together, right? So after having this system of equation, what we can do, we can say, okay, now we have inner brackets here that can be removed, right? So I will say, okay, then I will start with my 1. 1 times a -2 is -2. 1 times minus lambda is minus lambda. 1 times plus 2 lambda is plus 2 lambda. And then I said 1 times lambda square is lambda square. That stays the same. That stays the same. Let me see. Yes. But I'm not done yet because I still have my minus lambda. My minus lambda multiplied by minus 2 is plus 2 lambda, right? And my minus lambda multiplied by minus lambda is plus lambda, lambda square. And then my minus lambda multiplied by plus lambda square is minus lambda to the power of 3. And then now, because I open bracket, I can say plus 1 and leave that like that. I mean, after this step, we go down a bit and then work it out. And then we have minus. And then what I can do with the minus now, I can open break the other brackets and saying that, okay, minus multiplied by minus 1 is plus 1. Minus multiplied by minus lambda is plus lambda. Right? And then I can also open break the last bracket. Well, before I do that, the inner bracket says we have minus 1 plus 1 minus lambda. So if we take that, this will be 0, and then we will end up with plus. Minus lambda. Right? I hope you see the step we're making, because we're going through it very slow. Now this bracket can also be broken. But before I do that, I know that, okay, there is no other lambda to the power of 3, right? If there's no lambda to the power of 3, the first thing I will do, I will just take this lambda to the power of 3 as it is, because I know there's nothing that can be added to that or subtracted from it, right? But by the way, I see that this, yeah, that minus lambda minus 2 lambda, and that was plus. That was plus. Yes. No one saw it. This should have been plus because I multiplied this by 1, and this should have been plus. Because I was looking, okay, I now after taking the power of 3, I will look at the power of 2. Okay, I have 1 multiplied by this, and then I know that I have one thing. I can say, okay, I have 2 lambda plus 2 lambda, right? This 2 lambda plus 2 lambda will give us 4 lambda, right? 4 lambda to the power of 4 lambda to the power of 2, right? And then I should look at the lambdas. So be very careful when working with these. By the way, let me make sure that this was plus and this was 2 lambda. This was minus. Yeah. That, as you can see, you can easily make mistakes here if you don't do it systematically. Until here we cool, and then we say, okay, minus minus is plus, minus minus is plus. Lambda times this is 2 lambda to the power of that. So we have, I think there's a mistake, because we said, okay, lambda times minus lambda times minus 2 is minus 2 plus 2 lambda minus lambda minus times minus lambda gave us lambda plus lambda square, right? And then we didn't take this. We minus lambda multiplied by 2 plus 2
lambda should have given us minus 2 lambda to the power of 3, to the power of 2. I think we skipped that. Minus 2 lambda to the power of 2. Because we should have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So I got 6. Yes. So after we had the first one, 2. So after lambda was multiplied by lambda itself, lambda square, and then we have to I want to put it on the exact spot. Yeah. Which was minus, this is plus 2 plus lambda minus 1. This should have been minus 1. If this minus 1 and this was plus 2, this should have been 1. Okay, this is correct, and we have 1 here plus 1. Yeah, see it. There is a plus too much somewhere. I don't know if it's here or here. Let me figure it out quickly, because then because I know like the ultimate answer I have here is like lambda to the power of 3 minus minus 2 lambda. Well, I made some mistake somewhere I cannot see now. I'll make this good. I think this was a mistake, because I should end up with minus 1 plus 1, because I should get rid of these, and which will ultimately give, I will recorrect this before I send it to you guys, which will ultimately give me the following. This is like the disadvantage when doing things on computer, because then you don't see it. When I write it down, like on the sheet, I write it down, then everything seems to be correct. But yeah, then ultimately, because these two subtracted from one another will give us 0, we'll have this. And if I equals this to 0, I'll have the following. What I can do, like in the system of equation, I can still now use some bracket. Well, you see, like it's very easy to make mistakes. It's yeah. It's that now there's no mistake. Correct. So what I can do now, like as I said, if there is a lambda or a number, it doesn't matter what you have. Make sure that you know that okay, lambda on itself cannot stand. It is also it is multiplied by -1 in this case. So if I multiply everything now by -1, I will end up with lambda to the power of 3 plus, right? Because it becomes plus lambda to the power of 3 by multiplying everything by -1 plus 2 lambda equals to 0. And if I use a system of bracket to factorize it, the way if I say it properly, if you factorize it, what you have ultimately is lambda bracket lambda to the power of 2, lambda to the power of 2, so lambda square. So we will have what we will have is lambda square, because we're factorizing it plus 2. Plus 2, right? Plus 2 lambda. If you take the if you take the factor, you could also, by the way, leave it like this and then compute it. Then you could take minus lambda out of it and then do it, or you say I will leave the minus lambdas all up to you. Feel free to do what you think that's better or that works for you. Well, either way, like you know one thing for sure, that the first lambda outside of the bracket will be equals to 0, right?
Sorry, I think there's some slight mistake, because if you take
lambda
out of the here exactly.
Yeah, I saw it immediately. Yes, merci.
And then it's first lambda is 0, second lambda is plus square root of 2, and the
plus
minus, right?
Plus minus, yeah. Plus, yes. Yeah, so we have lambda equals to 0, and we also have lambda. And then you can say, okay, I have plus. Now I have a challenge again, because I'm at the same time I'm thinking, how am I gonna write the square root? Square root of 2. No, I don't say calculated. Yeah, I was thinking on how to do that. But for the sake of simplicity, let me say.
But what's between the brackets has to be 0, right?
What's between the brackets shouldn't be 0. I'm just realize I don't know who spoke. Who just spoke? Who was that, by the way? Was it Jan, or I don't know who just said like the answer already? I'm just like I have a
Yeah, it was me, but now that I see it's gonna be lambda squared is equal to -2. So
Yeah, and you can take the square root of
Yeah.
a minus.
yeah,
Oh,
so
yeah,
there will
yeah.
be no other answers other than lambda 0.
Yeah, that's what I meant.
Okay, wait. Then I think
Malik, you can write down square root by using sqrt, and then you see it in the chat.
okay. SQRT and then number. Okay, thanks. Let me think. I think this system. There should be a mistake somewhere then. Let me look at take a proper look at it. So what we did, we went through it. What's my pen? Yeah.
Do you still have like you have your answer sheet so we can just move on
So-
from that part and then maybe
Yeah.
later you can let us
Yeah,
know.
I think I will scan like my answer sheet and then send it to you guys, because I think it's because of the computer, a lot of numbers, and then you will get lost in the numbers itself. But I will write it down properly and scan that and send it to you guys. Sorry for the inconvenience. I think like the lot of L's and the numbers here confuses a bit. But the answer that you should get is we get as Jan already said, we get like this L equals to so SQR was said. So SQR was said. Let me see. SQR. And then I take one more there. So I take the square root of 2, but then I can say plus or minus. Or minus. So like then you can say the question that's asked like, okay, what are the eigenvalues? So the eigenvalues now in this case we have 3 eigenvalues. I mean the computer made it barely impossible to work out the equation, but I will make that good. I will send my answer sheet in a bit. Sorry for that, guys. But if you properly work it out with the lambda and starting off with the intuition that we gave here, how to subtract like the lambda from it, you should end up with a system that gives you that lambda is 0 and lambda is plus or minus the square root of 2. So that brings us to the answer by saying that, okay, we have we know at least that we have 3 eigenvalues, right? If you compute it, we have 3 eigenvalues, and from A we can compute L is 0, or we take L is the square root of 2, or minus the square root of 2. And what the guys said correctly, we can never take the square root of a negative number. I mean, in what Dutch people call wiskunde D, you have like they say, if you take a square root of a negative number in complex numbers, it will be imaginary. So in our case, that does not hold. It is imaginary. It's I. I mean, is I. In our case, does not hold. So it is not possible. You can, if you compute it and you have a square root and you have a negative number, please go back to your computation and compute it again. But the second part of the
Sorry, but actually I think on one of the last lectures, the professor said that this can be the case and that we should expect that the value may be negative and the square root may be negative, and that we should just express it in the terms of complex numbers.
Yeah, that's what I said. In terms of complex number, it holds, but in proper linear algebra, you cannot have or in proper math, you cannot have how do you call it, square root of a negative number, and in some kind of math they call it I as imaginary. I said because it's complex, right? But in this case, it wouldn't hold if that was the case. And so after computing the eigenvalues of A by saying, okay, it is 0 and it is square root of 2 and the negative square root of 2, then the follow-up question is, okay, can we say that it is diagonalizable? And I would like to have this answer from you guys before I write it down in the Excel sheet. Why? Because this is a theory question. I hope you have already gone through the theory a bit. So if we have three different, and I will give you a hint, if we have three independent eigenvalues in this case, can we say that it's diagonalizable? What do you think? I mean, in this case, it's a yes or no, and then say why. I have already given the hint, like that they are independent, the three of them. Anyone? If no one has it, like, okay, and then we'll refer back to what we've done above. So we have three independent. So we have, just write three out. We have three in the pendant answers, right? Like our
Wait, that's the answer already. If the matrix has linear independent eigenvectors,
then
it's diagonalizable.
Yeah, okay, thank you. That was what I was looking for. As I said, like if you look at the theory, so we have to do the question 5 and the second one. If you have gone through the theory a bit, and if you make something, it's okay. I have my eigen values, and I can possibly, because yesterday we did that. They gave us the eigenvalue, and we gave the corresponding eigenvectors. And now, if I have three eigenvalues, I know I can give the corresponding eigenvectors, which means that I have three independent eigenvectors. So saying that, if I would just say, if you look at it, we now have three independent eigenvectors, just by saying, because we have three independent eigenvalues. That's why I conclude that we have three independent eigenvectors. We have not computed the eigenvectors again, but we know we have three independent eigenvalues. So by saying so, we can say, conclude that the matrix is diagonalizable. So yes. Do you guys get?
Can I just ask, for the exam, whenever he's talking about, like, make sure you write the theorem, all the theorems, like, there's a million of them.
Yeah.
And how are you supposed to, aren't some of them like starting over between chapters, like theorem 9, there's another theorem 9 kind of thing?
Yeah.
So how much information about the theorem, or can we just say, I used the theorem regarding blah, blah, blah to
be honest, like, I feel very sorry for you guys for that, because like last year it was on test vision and he didn't bother us with that. It was just like, you did a calculation. The important thing is that you make sure you had the correct answer. That was also what bullied more people, because you couldn't, like, it was, as you can see, this was a setup of test vision. You could just give your answer and that was it. And yeah, like, you have to know all the theorems, unfortunately, but you don't need all the theorems, because depending on the question that's asked, some theorems are corresponding to that and some theorems are not needed for that. So yeah, that's the only thing. The bad news is that you have to know everything, and the good news is you don't have to apply everything. Okay.
But I remember, if it has a name, you have to mention the name of the theorem. And if it doesn't, then just state what you are using. I think that was the point.
Yeah, but at least you should know what you're applying. If you don't know what you're applying, you cannot also mention the name. That's why I said, like, make sure you know which theorems are discussed in the book. And for now, like, we have some time to discuss, like, the I'm for sure going to lose points. No problem, Alexander. If you make sure that you do the rest good, then for the computations, you should.
The recording has stopped.
Points. But for now, we can use some time, like maybe if needed, like 10 minutes, quarter of an hour to revise some things. And definitely, my bad for this. I will rewrite this on paper so you get it clearly, because find even this buggy, I will write it on paper and then write it there again and then send it to you guys. And I hope that the setup of it and the intuition you should get to compute it is clear, because I ended up with this and then I computed it like this. And then make sure that you keep that way of computing, or at least your way of computing it, so you get the proper answer. Well, for now, if there is any other confusion, like any other thing that confuses you, feel free. Now I stopped the recording. No one else will be able to hear you if they were watching. Just feel free. Like, there are stupid questions do not exist, and we're here to learn. And if you're confused with something, just ask it.
So you mentioned the orthogonal ones. Those are the ones that are very common across all the years. Is there another one or two types that we should take a look for sure?
If you're lucky, you'll start with this, and that's I can basically those are 3 points. This one, if you're very lucky, because 2 times that we get that, like it gives us the homogeneous system of linear equation, and they say okay, just show the inverse matrix. It's 2 times the same, just different homogeneous systems.
And you were also pointing out that 2 of the questions have the same kind of way, like different phrasing of asking for the same thing. I think it was the Y space thing. Can you explain that was again?
Yes, these 2. Oh, you mean the Y space? I said like, okay, yeah, I think I know what you mean. Like the Y space here, that when they say okay, ax plus x is y, we have to add the y. Let's say what the y is in this case, y1, 2, and 3, to make sure we calculate it and ultimately have our pivot points, pivot columns, where we know that the pivot y3 is the free variable, because we can add that we can say 0 equals to this, right? And ultimately, if we go back, it was in this case 1, 2, 3, third exercise. No, it was our second, third exercise, just for a second. So what we did, first of all, we took our X to be our identity matrix, and in our third one, when they asked us what we solved today, which was different, it was asked differently. So they gave us this, and then they say, okay, but Y is Tx. So it is really different. When they say here that ax plus x is y, but here we express y into other things, and that's why everything that we calculate here will be y. And in this case, everything, as you could see, like in the today's session, when we started, we ended up with y as this, and in the first case, this was our answer to the first exercise, first exercise, and we could work it out, and then ended up with I think this was yesterday, my bad. So like today we express it like this in our first exercises, and then knowing that y3 is our free variable, we could just derive our v again, and then that was the hard way, and the easy way we could do it like this. So there's a different way of asking more or less the same thing, but you should really keep in mind and go through the questions again and know that, okay, if they ask this, I should make sure that I compute it like this, and if they ask that, I should know that I compute it like that, because that will help you a lot.
And for that specific question we're looking at right now, I had another question. It was we got you were showing the hard way to get the u and v vectors, and then you row reduce. You only picked the u and v columns, right? Because you only need 2 vectors. Is that
you mean the easy way, right?
No, the hard way. Yeah, you selected 1, 2, 3, 5, 6, 7, but in the linear system, there's like a third column, right? But we ignored that. Can you tell why we
do not ignore it? We couldn't take it because there was not a pivot column for that. The third column, the y3 is 0. Okay. Yeah, and we know that this is 1, and we can make this 1 if necessary.
Gotcha. Okay, thank you.
Yes, we never ignore things. We look at our pivot columns, and that's why I took these 2 as being my pivot columns. Okay, any other questions?
Yeah, I have a question for the fourth question. No,
Yes.
no. Sorry, the last one we did.
The fifth one.
Yeah.
Yes.
Yeah, for the about the conclusion.
Yeah. The conclusion for the
You-
second one.
Yeah.
Yes.
Because I'm not sure if can you say that if you have 3 eigenvalues that you have 3 eigenvectors? Because I'm not sure if that is the case.
Sorry,
Like,
if I can interrupt,
Yeah.
by the diagonalization theorem,
Mhm.
square matrix n by n is diagonalizable if and only if has n linearly independent eigenvectors. So
Yeah.
Thank
saying
you.
that we have 3 independent eigenvalues means that we have 3 linearly independent eigenvectors, which in turn
Is that
mean,
so?
sorry?
Is that
I think he's just reading the theorem now. He's not saying by heart, right, Jan?
It's half of it is the text, half of it is me looking at the text,
Yeah.
as the other half is me interpreting it like real time.
Yeah. No, that I'm trying to say tell Max that because Max ask you, is that so? I mean, if it's in the book, we shouldn't argue it. We should just memorize it and do it.
No, I'm not sure if what Jan said, if that is in the book. Like the first part is definitely in the book about if and only if there's in linear independent eigenvectors, then it's diagonalizable. But now we have eigenvalues, and the theorem about eigenvalues was if a n by n has n distinct eigenvalues, then a is diagonalizable.
Yeah, distinct.
Yeah.
Another word for distinct is, I mean, being a bit different, right? And
yeah, distinct are what's the different?
different. Original, and then they should be independent from one another. So that's why we,
Yeah, but that's talking about eigenvalues, not about
fact-
eigenvectors. And my question was, can you say that if you have 3 linearly independent eigenvectors, does that imply that you have also 3 linear independent eigenvalues? The other way around. I'm sorry. If you
I know, I get you, but we'll go to an example to show it properly. Like in case the second question I mean, the third question we discussed yesterday was the second question of the actual exam. We saw there that they gave us like one eigen value, and from that we could compute the eigenvector W. In case that there were multiple eigenvalues for this A, let's say we have -1, we have 1 and 2. I can assure you that we would have other eigenvectors which are independent from the other from the W. So then we can say that we have 3 independent eigenvectors.
Okay. Yeah, that's what I wanted to make sure. Is like if you have if 3 or whatever n number of eigenvalues, does that mean you get the same n amount of number of eigenvectors?
And another thing to keep in mind, sometimes you have the same eigenvalue. So basically you have different eigenvectors, but you have the same eigenvalue. Therefore, it would become as, for example, instead of another one, it would be the same.
Yeah, but then it's not distinct. And then because there was a theorem, if a has the number of eigenvectors, and then depending on the dimensions, there was something about that. Like if you have 2 of the same value, I remember there was something about that with the dimensions of those eigenvalues. Like if you have if you get 2 times lambda is 2, for example, if you get that twice.
Yeah, but then if you get 2 times lambda is 2, then you know they are not independent, right?
Yes.
So in case our answer was lambda is 0 and lambda is the square root of 4. I'm just saying something. Then we know that we will not even like the square root of 4, but because we have 2n minus 2. But let's say that we know that we have 2 times 2 in 8, right? We have lambda 0, we have lambda is 2, and lambda is 2, so we know they are not distinct. Then we could say it was not diagonalizable because we could not have 3 linearly independent eigenvectors from it, because we know if we.
Okay, but let's say you get like 3 lambdas. One of them is 1, and the second one is 2, and the third one is 2 as well. I think according to another theorem, that if you get 3 of them, with one of them with dimension 2, since the 2 has 2 of them, you can then and if that still is equals to n, it is still diagonalizable, because now we only get 2 eigenvectors. But since
But then, yeah, then you should take one of the two, right? Then you should consider just one of the twos because they're the same in that case.
yeah,
If you want
so,
to,
yeah,
if
so
you want to make a
only
dialogue,
2
yeah,
eigenvectors,
Yeah,
you get another one, but it's still diagonalizable since it's the n of eigenvalues with the dimension 2 equals to 3 if it's a 3 by 3 matrix.
Yeah, but then you cannot say you have 3 linearly independent eigenvectors, right? You have 2 linearly independent eigenvectors. Yes, yeah. Then it makes sense, but you cannot say 3 because if you say 3, they are not independent because you have 2 that are the same, that are dependent in that case. Yes. More questions? I like this phase, by the way, because then I think people that are asking most questions are trying to get more intuition in things, how they should be applied. And that will help you the most, believe me.
I add one more small thing.
Yes, sir.
For the determinate, how's it called again? Determinant. What we did with the easy matrix, with the ones on
the easy way. The easy way.
Yeah, we're at a fairly simple matrix, right? With 1, 1, -1, 1, 1, -1, 1, 1, -2.
Yeah, and what I wrote down here is like the answer what I had here. I didn't do this.
No, this is not the one I meant. This it's one question down, I think.
Yes.
No, one more. This one. Yeah, below. Yeah, this one.
This one.
Yeah. Then we get the determinants, right? So we have to lambda.
That's after here. This is from here we can get the determinants.
Can we row reduce this such that there are more zeros, such that there is an easier calculation for the lambdas?
I wouldn't recommend it.
Because then you change the matrix, right?
Yeah.
Okay. Because if you have a triangular matrix, you just take the diagonal and multiply that.
So if you row reduce it, you make life more harder for yourself than necessary.
Because my first thought about this question was, let's make a triangular matrix by row reducing it and make the bottom half zeros, and then just take the product of the diagonal. That was my first way of thinking about to solve this.
No, I wouldn't do it like that. I would just really take the dependence and then put it in a system of equation and make sure you don't make like the stupid mistakes I have just made, unfortunately. And make sure you don't get lost in the amount of or the length of the equation. And especially when you write.
Can you do it that way? Is it equivalent or not?
I wouldn't know, to be honest. Being honest, I wouldn't know because I've never tried like that.
Okay, and then follow-up question for this. Sorry, but I kind of
no. I like the interaction. I think other people are also learn from it.
Say you make the bottom 2 on the left, on the last row, zeros, for example.
Again.
The bottom left of the matrix. Yeah, if you the ones those two, say they are 0 for any other case.
Then you just take 1. Then make life easier for yourself. If these are zeros, then you just have to take this dependent, and because 0 multiplied by anything is 0.
Exactly. You take those zeros as well, so you don't take anything else in account, just the determinant of that one.
But I can assure you they will not do that because they know that's way easy. To do it. They will not do that.
No, true. And that's why if you reduce it, if you start row reducing it that way, then you still get only one.
But the problem is, if you want to make these 0, then you should use this as multiplier. So let's say I use this as multiplier, and I know that. So I should come up with a number that multiplied by this will give me -1, and I add to this to make it 0. And just tell me what that should be then, because I have problem with the lambda.
Yeah. But you can subtract to take the third row, you can just subtract the second row from the third row.
Yeah, by subtracting the rows by themselves, then you can have also another matrix, right?
I wouldn't really recommend that way of doing it, to be honest.
Okay.
But if you prefer it, you can try it, but I wouldn't recommend it.
Yeah, I was just wondering if it's equivalent if you do it like that.
No, because you
with
have
different-
like a different matrix at the
Yeah,
end of
and
the
then
day.
you get the different. Okay, yeah, that's what I was wondering. Okay.
Yeah. Yes, more questions? Okay, I think if there are no other questions, as promised, I will redo the fifth question, especially the first phase, write it down and send it to you guys. As yesterday, you will find the recording in your mailbox or in your spam. Please check that out because I tested it on my own mail first and then saw that it was in my spam. That's why I resend the email by telling you guys to look in your spam if you don't find it. And I will send the materials again and make sure please that you prepare well for the exam because the reason I'm doing this, like I have an exam tomorrow and an exam on Tuesday and on Friday, but the reason I'm doing this is just really help you guys and make sure that you pass it. And if you pass it, I will be happy. I will really be a happy guy, and not just me, but that's Rems too, and also Amalia. And so please do some effort for yourself also, so we can know that our work has also been worth it. Okay, our work and time and energy has been worth it. Yeah, so after saying that, guys, I don't have anything to add to it anymore. I will wish you all a good exam week, and by good I mean like a successful one, so you pass all your courses. And I will, by the way, see most of you guys tomorrow at machine learning because I'm retaking it from last year. Last I wasn't like not happy with my grades, so I will see most of you tomorrow. But make sure that for linear algebra that you do your best and have good grades. Guys,
You too.
good luck.
Thanks.
Bye.
Ik geloof het wel. Ik zie je morgen.
Yes, ik zie je morgen, Max.
Examen.
Doei.
Later.
Okay. Rems, je vais t'appeler sur ton portable.